Hello, welcome back to this video 5-4, and here we're going to talk about the candidates test, which will help us determine where absolute maximum and minimum values are for a function. So here are the steps in order to find the candidates for the absolute or global extrema. Step number 1, you're going to go ahead and you're going to find the critical values in a given interval. What you'll do from there is you'll go ahead and create a table of values, and what you're going to do is you're going to include the critical values and endpoints. Include the critical values and the endpoints. Now, when you're finding absolute extrema, what you're going to do is you're going to plug x values into the original function, which I'll say the function equation here. So you plug them into the original one. These x values, the critical values and the endpoints, these are your candidates, what we call the candidates for the global extrema. Now, once we've plugged these values in, the greatest value is the absolute maximum and the least value is the absolute minimum. Makes sense. Now, you're going to go ahead and give the absolute minimum or absolute maximum the following wording. So we would say the absolute maximum is whatever it is at x equals whatever that x value is. Now this is your y value or your output, and this is whatever your x value is. Now the same thing here, right? So the absolute minimum is whatever that minimum value is at x equals whatever that x value is. Now note, a couple of ways the AP exam will ask this question. They may say, what is the absolute maximum of f of x? Or what is the global maximum? Remember, these two words are interchangeable. And find the maximum value, or what is the maximum of f of x? All of these refer to the absolute or global maximum. Okay, so what we're going to go ahead and do, example number 3, let's go ahead and look at some of these situations. Example 3, find the absolute extrema for the following functions. Here I have f of x equals 2x squared minus 8x plus 1 on 0, 3. Okay, so what I'm going to do first is I'm going to go ahead and find my critical values. F prime of x is equal to 4x minus 8. Now I'm going to set this equal to 0 in order to find the critical values, and I'm going to go ahead and solve. So we get x is equal to 2. That's a critical value. That's one of my critical values. Note, sometimes these critical values are not inside of your interval. So notice my interval is 0 to 3, so I'm going to go ahead and include this one. Now what I'm going to go ahead and do is I'm going to make a table. So x, and then I'll say here f of x. And my critical values are 0, 2, and 3. Again, these are my endpoints, 0 and 3, and 2 is my critical value. Okay, so I need to go ahead and test these because absolute values can occur at endpoints. I'm going to plug these directly into my function here. So we have f of 0, that's 2 times 0 squared minus 8 times 0 plus 1, which gives us 1. So there is that value. Now I'm going to go ahead and plug in 2. 2 times 2 squared minus 8 times 2 plus 1. Which gives us 8 minus 16 plus 1. So we have negative 7, I believe. And then the third one, 2 times 3 squared minus 8 times 3 plus 1. We're going to get 18 minus 24 plus 1, which is negative 5. So all of these values I just plugged directly in, these x values, I plugged them directly into my function. Now what I need to do is I need to determine what is the absolute extrema. So I'm going to say the absolute maximum is whatever the absolute maximum value is. It is 1 at x is equal to 0. There you go. There's the absolute maximum. Okay, what about our absolute minimum? the absolute minimum is -7, and this occurs at x equals 2. There you have it. That's the candidates test. Okay, let's go ahead and look at B. Okay, g of x is equal to x squared minus 1 squared over 2 on the interval -3 to 2. So the first thing we're going to go ahead and do is differentiate this. So we have 2 times x squared minus 1 over 2. And then I'm going to go ahead and also multiply times the derivative of the inside, which gives us 2x. And I'll clean this up. We have 2's that cancel, so we have x squared minus 1 times 2x. So I'm going to set this equal to 0, and then we'll use the zero product property. So I have 2x is equal to 0, and x squared minus 1 is equal to 0, giving us the critical values 0 and plus and minus 1. Okay, so there's my critical values. Now what I need to do is just make a table. So I'm going to make a table x and g of x. That just reminds me to plug it into the actual function equation, into g of x, not g prime. And my critical values, in addition to my endpoints, give us -3, 0, or sorry, -3, -1, 0, 1, and 2. And I'm going to plug these into my function. So it looks like we have 9 minus 1 squared. That's going to give us 8, 64 over 2 is 32. If I plug in -1, we get 1 minus 1. That's 0 over 2, so there's 0. If we plug in if we plug in 0, we get -1 squared. That's 1 over 2, so 1/2. And 1, if I plug in 1, giving myself some extra space here, that's also going to give us 0 over 2, which is 0. And then if I plug in 2, we get 4 minus 1, 3 squared is 9 over 2. So there's my table values, right? And we just plug those directly back into g of x. And then now we're going to go ahead and just determine what is the absolute maximum, what is the absolute minimum. So it looks like our maximum value is here at 32, and our minimum value is here at -1 and 1, which gives us a value of 0. So we can say the absolute max is 32 at x equals -3, and the absolute min is 0 at x equals plus and minus 1. All right. So there's B. Okay, next example. We have C. Find the absolute extrema of h of x, which is x squared over x plus 3. Okay, so I need to find my critical values. Those are part of my candidates. We're going to go ahead and take a derivative. We have 2x times x plus 3 minus derivative of the bottom, which is 1 times x squared, all over x plus 3 squared. So if we clean this up, we get 2x squared plus 6x minus x squared over x plus 3 quantity squared, and this will also give us x squared plus 6x over x plus 3 squared. Okay, so with this function we have a rational function. Remember, you get critical values. You get critical values when h prime is equal to 0. Okay, and for this I'm just going to set my numerator equal to 0, and I can factor this. So we have x is equal to 0, and x plus 6 is equal to 0, which gives us negative 6. So here's two of my critical values. Also, I have to account for where h prime is undefined, and that comes from where our denominator is equal to 0. So we have x plus 3 equals 0. There's two of them, but that will be suffice if I just look at one. Okay, and I have x equals negative 3. Now, before I go ahead and plug this into our table, x and h of x, to go ahead and find this, note your endpoints are negative 2 and 1. So anything outside of the endpoints, we're going to throw away. So negative 3, that's outside of negative 2 and 1. I don't care what happens there. Also, negative 6, I don't care what happens there. That's outside. So my only critical values are negative 2, 0, and, my only critical value is 0. My endpoints are negative 2 and 1. Okay, so those are my three candidates. Now we're going to go ahead and test this. So when I plug this in, we get 4 over 1, which is equal to 4. If I plug in 0, we get 0 over 3, which is 0, and 1 over 4. Okay, so there's our values. All right, and then our conditions, our conclusions, not conditions. The absolute max is 4 at x equals negative 2. The absolute min is 0. 0 is the minimum at x equals 1. Okay, and there you have it. All right. This would not be complete without throwing up a trig example. So here is a trig example. Y is equal to 2 sine of x minus 1 on 0 to 2 pi. We're including 0 and including 2 pi. So we have our derivative. Y prime is equal to 2 cosine x minus 1. We'll go ahead and set this equal to 0 and then solve. And so we get cosine of x is equal to 1/2, okay? And on the unit circle, cosine of x is equal to 1/2 at pi thirds. X is equal to pi thirds. And then also in quadrant number 4, where cosine is positive. So cosine is positive in 1 and 4. So that's going to be 5 pi over 3, okay? So we'll go ahead and generate our table x and y, and we get 0, pi over 3, 5 pi over 3, and 2 pi. It should be worth noting that 0 and 2 pi are extremely similar. So note, oftentimes one of them is left out. One of them's excluded. Here, they're both included. So just be careful. I'm plugging these into the actual value, so I'm going to compute both. Okay, so we have 2 sine of 0, 2 sine of 0 minus 0, which just gives us 0 minus 0, so that's 0. Pi thirds, we have 2 sine of pi over 3 minus pi over 3. Okay, and I can go ahead and I can compute this. So we have 2 sine of pi over 3 would be root 3 over 2 minus pi 3. So these cancel, so we have root 3 minus pi thirds. All right. 5 pi over 3, okay, so same idea, 2 sine of 5 pi over 3 minus 5 pi over 3, and this gives us a negative 2 times negative root 3 over 2, okay, minus 5 pi over 3. So negative root 3 minus 5 pi over 3. And then we have 2 pi. So 2 sine of 2 pi, that's also going to be 0, but this time we're subtracting 2 pi, so we get negative 2 pi. All right, so the rest of these values are going to require a calculator. I would assume that you would have access to a calculator for these computations. The value for pi thirds, this is 0.6848. Negative root 3 minus 5 pi over 3, negative 6.9680, and negative 2 pi, that's approximately negative 6.2831. So these are very, very close. I can't imagine they would have you compute this without a calculator. So given here, we can see that our absolute maximum occurs at pi thirds, and our absolute minimum occurs at 5 pi over 3, okay? So we can say the absolute max is root 3 minus pi over 3 at x is equal to pi thirds, and the absolute min is negative pi over 3 minus 5 pi over 3 at x equals 5 pi over 3. Okay? And there you have it, the trig example. Okay, looking at question number 4, example number 4 requires a different kind of thinking. And they say the function of g is differentiable on the closed interval 0 to 6. The graph of g prime, the derivative of g, is given to the right. At which x value does the graph of g have its absolute maximum value? Okay, well, it's important to note that g prime is equal to 0 at x is equal to 0, 4, and 6. Additionally, these are our endpoints, 0 and 6. So here are my candidates. Here's my candidates. And again, if I wanted to find global maximum, absolute maximum, I could make a table, and these would be our candidates. Now, the problem with this problem is that I'm not given any information about g. I don't have a function value. But what I do have is I do have g prime. Now, on a g prime sign chart, if I went ahead and listed these, 0, 4, and 6, you can tell that g prime is positive between 0 and 4. So therefore, I know that my function is increasing. It is negative between 4 and 6, so I know that it is decreasing. Okay? And they say, at which x value does the graph of g have its absolute maximum value? Now, we can see 4 is a maximum, but thinking about this, is it the absolute maximum? Is it bigger than 0? 0 could be a maximum too. Think about it. Well, if I'm increasing from 0 to 4, if my function's increasing, doesn't that make 4 bigger than 0? I would say so. And then if we decrease at 6, well, if I'm decreasing at towards 6, then my function's getting smaller and smaller. So therefore, at x equals 4, we have an absolute maximum value. Okay, so we'll go ahead and respond to this. We say g has its absolute max value at x equals 4 because g increases on the interval 0 to 4 and then decreases on 4 to 6. Note, I'm not referencing G prime here. They're not asking about a relative maximum. If they were asking about a relative max, then our justification would be G prime changes signs from positive to negative at x equals 4, okay? But here they're asking about the absolute maximum value, so you have to use a little bit of critical thinking here, and especially with your explanation, okay? All right, that is pretty much all of the new information that I have for you. I do want you to try example number 5. It's a blend with an exponential and a trigonometric function. Go ahead, pause the video, try to find the maximum and the minimum values of k of x on the interval 0 to 2 pi. All right, here is the solution to example number 5. The first thing that you had to do, you had to find your critical values. So that involves taking the derivative of the function and then setting it equal to 0 or finding out where it's undefined. This gave us our critical values, x equals pi over 2, 3 pi over 2. These are your critical values and can contain relative extrema. Next, 3, in order to determine the global or the absolute extrema, we go ahead and evaluate those critical values along with the endpoints, 0 and 2 pi, in our table of values. These are your candidates, your endpoints and your critical values. Whenever that question pops up, what are the candidates? Critical values and your endpoints. So we go ahead and evaluate these. If we plug these into our original function k of x, k of 0 gives us 1, k of pi halves gives us e, k of 3 pi over 2 gives us 1 over e, and k of 2 pi gives us 1. So our absolute maximum is e. It's approximately 2.7 at x equals pi halves. And then k has an absolute minimum of 1 over e, 1 divided by 2.7. Okay, and that occurs at x is equal to 3 pi over 2. That's going to do it for this video on absolute extrema. Remember, in order to find the absolute extrema, you're going to utilize the candidate tests. Who are the candidates? Critical values and endpoints. Give me a thumbs up, like the video, subscribe. See you in the next math video.